In this video, I want to do a little bit of reviewing and then edge towards talking about testing the difference between two distinct samples and their means, as well as confidence intervals for the difference in two sample means. I'm going to do some work here very quickly because many of these tests begin to become very similar, okay? So, a student conducts a survey to determine if the proportion of girls with blue eyes is greater than the proportion of boys with blue eyes at her school. So she finds 15 out of 35 girls, 14 out of 40 with blue eyes. So, we're going to do a state plan, do, conclude, to build a confidence interval. So let's start with the state. Okay, so if you remember, we just have the statement that we're going to make a 95% confidence interval for the difference in proportion of blue-eyed girls and blue-eyed boys in the school. All right, next is the plan portion of this. So let me just run through these conditions. We're doing a two proportion Z interval. We have a simple random samples. They have to be independent. And then you can see those, those 1/10 conditions. 35 is less than 1/10 all the girls. 40 is less than or equal to 1/10 all the boys. N times P is bigger than 10. N times 1 minus P is bigger than 10 for both boys and girls. Remember, a lot of this was similar. The big added one was this idea of independent samples. Now, the do portion of this, we're going to use the calculator. Okay, so we went into the calculator. You get to two proportion Z interval. See my data. I hit calculate. This is what I got. So my do is negative 0.412 to 0.299. So now let's do that conclude statement. We are 95% confident that that interval from negative 0.412 to 0.299 captures the true difference in the proportion of blue-eyed girls and blue-eyed boys in this school. Okay, so we've now completed the first part, the confidence interval. Now the next part says conduct the appropriate test of significance. Okay, some of these things are going to be similar. I'm going to write some of this stuff in blue. Okay, the state for this, of course, we have a null, and the null, remember, is that these things are the same. So we'd say, okay, so the proportion of boys is equal to the proportion of girls. I'm sorry that I don't have a lot of room, so it's kind of sloppy. And remember, we can use subscript here, right, to kind of save ourselves, once we're with two samples, save ourselves from having to define the parameter. Our alternative is the proportion of boys, and actually I said here that the is greater for girls than for boys. Yes, so is less than the proportion of girls. Okay, so that's our state. Our plan, obviously we need to say it's a two proportion Z test, but other than that, everything else should be the same. We'll talk about being a simple random sample and independent. We have to talk about all of these conditions as well. Okay, our do is going to look a little bit different. Okay, so I went into that menu, two proportion Z test. You can see the girls and boys, they were actually already filled in for me. I needed to be a little bit careful here because I'm having that there's a higher proportion of girls than boys, so I had to do a greater than. The P1 is greater than P2. If you had accidentally done it the other way, then your P-value would be the complement of what it is. And we really should be looking for something other than 0.5. That's a big clue that our inequality is incorrect. So what I need to write down is simply the Z statistic. You need your test statistic. It's 0.697, 1 I guess, and you need a p-value. It's 0.2429. And now we need a conclude. I'm going to put that right here. So, and actually let me change my mind. Let me write my conclude up here where I have a little bit more room. We fail to reject. The null. Because the p-value is larger than 0.05. And then we got to say what that means in context. Okay, I'm going to take you through this. I'm sorry for my kind of organization on this. We fail to reject the null. The p-value is too big. So we do not have enough evidence to say there is a difference in the proportion of girls and boys with blue eyes. Okay, so remember, this conclude really has three parts. What did you do in terms of the null? Why did you do it? And then what does that mean in context? Okay, so this was just a review of the things we've done with two proportions. Let's move on.